Hi friends, I am Vinod Chankaran. Welcome to another episode of my channel. Today we are going to discuss about gauge repeatability and reproducibility. Measurement system error has got two elements mainly. One is accuracy and the second one is precision. This accuracy can be further classified into stability, bias and linearity, whereas the precision can be classified into repeatability and reproducibility. And this repeatability and reproducibility is better known as gauge R&R. And the purpose of gauge R&R is to quantify the variation in the measurement system due to repeatability and reproducibility. We will further look into gauge R&R study with one illustration. So we will select three persons, 10 parts, and three trials for this study. Each person will check each part three times. Part number one three times, part number two three times, part number three times, up to 10. Similar to that, operator number two will be checking each part three times, followed by the third person. So there will be 10 parts into three operators and each person checking three times. There will be put together 90 observations for this study. Now let us see how we can do it in using Minitab. There are three operators: Lala, Mohinder and Surinder, and there are 10 parts and each part is checked by three times by each operator. So operator one is checking part number one time, two time, three time. Similar to that, he is checking the part number two one time, two time, and third time. Similar to that, part the operator number two is checking the part number one three times, two three times, and so on and so forth. Now we will see how we can do it using a gauge R&R study, quality tools, gauge study. Here you have to select gauge R&R study crossed. Here I have chosen X bar and R. In this gauge information you can put the gauge name, date of study, reported by, etc. And in options, if you know the specification limits for the parts, you can enter lower specification and upper specification. Then you have to choose the parts, operator and observation. Now you have to say OK. Now you will get two windows. One is the graph window, the other one is a session window. We will look into the details of that. Minitab gives percentage contribution table and study variation table. So first we will look into percentage contribution table. Here you can see that there is an element called total gauge R&R. This is actually the sum of repeatability and reproducibility. So it is 0.84 percentage. Next is repeatability. So repeatability means the variability in measurements when the same operator measures the same part multiple times. So when the same operator measures the same part multiple times, the variation between those measurement is called repeatability. Reproducibility is the variability in measurements when the different operators measure the same part. So when the same part is measured by different operators, what is the variation is observed, that is called a reproducibility. And part to part variation, the variability in measurements due to different parts. So different parts has got different dimensions. So that is what is part to part variation. Now if you see the contribution table, percentage contribution table, you can see that Total gauge R&R is only 0.84%, repeatability is 0.76%, and reproducibility is 0.08%. The major is the contribution is due to part to part variability, that is 19.99.16. Now, what is the acceptance criteria for that? Let us see. If the total gauge R&R is below 1%, the measurement system is acceptable. So here our total gauge R&R is 0.84. That means this measurement system is acceptable. Between 1 to 9%, the measurement system is acceptable depending on the applications, the cost of the measuring device, cost of repair, or other factors. And greater than 9%, the measurement system is unacceptable and should be improved. Next, we will look into percentage steady variation table. Here you can see that the total gauge R&R is 9%, repeatability is 8.74%, reproducibility is 2.84%. Now, if the tolerance of the part dimensions are given, then total variation is replaced by tolerance. If the tolerance is given, you can check this table. Here also the total gauge R&R is 7.87%, repeatability is 7.48, and reproducibility is 2.43%. Now, what is the acceptance criteria? The acceptance criteria is that if it is less than 10%, if the total gauge R&R is less than 10%, the measurement system is acceptable. So you can see that in both cases it is less than 10%. Between 10 to 30%, the conditionally acceptable depends on the application, and more than 30%, the total measurement system needs improvement. Next, we will look into number of distinct categories. Number of distinct categories, in our case, it is 15. Now let us look into the definition of NDC, or number of distinct categories. NDC represents measurement system capability to detect and indicate small changes in the characteristics measured. For example, we cannot use an ordinary weighing scale for measuring the weight of the gold. We need a weighing scale with a high resolution so that it can detect even a small change in the weight. It can be detected by this kind of weighing scale rather than using the normal ordinary scale. So in this case, the NDC for this part, this weighing scale is much higher than the weighing scale of the normal type. Now, acceptance criteria. Here, if you can see, when the number of distinct categories is less than 2, the measurement system is of no value for controlling the process, since one part cannot be distinguished from another. When the number of categories is 2, the data can be divided into two categories, say high and low. When the number of distinct categories is 3, the data can be divided into three groups, say low, middle, and high. And a value of 5 or more could be an acceptable measurement system. Next, we will look into the graph. First, component variation graph. This indicates that the largest component of variation is part to part variation compared to gauge R&R, repeatability, and reproducibility. And ideally, the largest component variation should be part to part variation. Next is R chart by operator. This denotes whether any point fall above upper control limit. If the operators measure consistently, the point should fall within the control limits. And X bar chart by operator. It shows that whether most points fall beyond the control limits. The paths which we choose for gauge R&R study should represent distinctive part-to-part variability. Thereby, we should expect more variation between part averages, and the graph will show that most of the point falls beyond the control limits. Next, observation by parts shows whether multiple measurements for each part are close together. Multiple measurements for each part that are close together show small variation between the measurements of the same part. So if you really see here, there is only a small variation between the measurements on individual part. If there is a large variation, that means the measurement system is erroneous. Next, observation by operator. This indicates whether differences between operators are small compared to the differences between parts. A straight horizontal line like this across operators indicates that the mean measurement for each operator are similar. So in this case, you can see this is more or less similar because it's more or less straight line. Ideally, the measurements for each operator vary an equal amount. Now, if there is a large variation, then the graph will be something like this. That shows that the measurement system is not adequate. Operator part interaction graph. Lines that are coincident indicate that operators measure similarly. So in this case, you can see that almost all the points are touching each other. So this shows that the operators measure similarly. Lines that are not parallel or that cross indicate that an operator's ability to measure a part consistently depends on which part is being measured. Now suppose one of the points are away, some other points are same, or one of the points are away. If that is the case, then that is indicated that the operator's ability to measure the part consistently depends on which part is being measured. So some part they are able to consistently measure, some part they are not able to consistently measure. So if that is the case, that would have be the indication some of the points will be away from the other points. Now, a line that is consistently higher or lower than the others indicates that an operator add bias to the measurement system by consistently measuring high or low. Now, suppose some points are going up or down compared to other points, if some points are away from the other points, like here or some other place, that shows that one of the operators compared to other operators having a bias in the measurement system. But in this case, you can see that more or less all are touching each other, means this is a shows a good parts and operator interaction. Similar to that, this is a straight line indicates that this is a good measurement system and it is observation by the operator are matching each other. Similar to that observation by parts also, you can see there is a small variation on each part.